All right, welcome everybody. Welcome to the programming live stream. What we're gonna do today is work on the app that we've actually bootstrapped before. Actually, what I'm wondering is, can I make this even bigger? Yes, I can. Okay, let me go back then and switch the font settings back up. So let's make this like 16 or something. 16 should be fine. Is this readable for everybody? Is this good? Is this editor nice? Is this good enough, good readable code right now? Are we chilling? So what I changed is I'm streaming from a main monitor now, which means that everything is high resolution, which means that on stream everything might be a little too small. But I did upscale everything, so I think the only thing that's like a little tiny now is the GitHub screen, but that's, I guess, fair. You guys won't be looking at that too much. It's been a very long time since we've actually bootstrapped this project, and I don't even know if it still works. I don't even know how to start it up again. I think it's Mix Phoenix server, if I remember correctly, and it is correct. And this is basically the website that we built. So this is just the Phoenix framework. For those of you that don't know what that is. Oh god, I'm searching for Phoenix on Google. That's not great. Phoenix Elixir, which is a framework. It's just a web framework that has a lot of cool stuff inside of it, like WebSockets and like real-time data and all that shit. So that's cool. That's awesome. A productive web framework that does not compromise speed and maintainability. Exactly. And I really like how the way this is set up, because it really drives you to build your application using domain-driven design, which is pretty interesting to me. Welcome Yen, welcome Cad, welcome. Well, Zen, I already said hi to Zen, but welcome Zen. How's it going? I'll text you. Don't want to spam voice chat. Sup twos. It's all good, man. It's all good. Sup Blossom Void. Sup Sarah. Sup Jay. How's it going? Just Chan, thanks so much for the host, as I said earlier. And Jeroen, welcome to the stream as well. Sup Richie. So how does this set up? It's also a good reminder for me, because I haven't touched this in a very long time. You have multiple domains, or not really domains here, but you have multiple output ways of outputting, basically. So you have your normal lib here. Inside lib is basically your entire application. I don't even know why we have a web here, by the way. I don't know. Is this? Oh, this is just an empty folder. Okay, that's all good. Let's delete that, because I was like really confused. So inside lib is your main like libraries, like your main application. So this is where most stuff is. So as you can see, I have a folder JuzzRCats, I have a folder JuzzRCats web, I have a JuzzRCats web ex folder, and a JuzzRCats folder, which is basically just defining the module. So so that's great. Here is all the web related stuff. So this is basically just setting up the JuzzRCats web domain, which is just outputting, and it has its own like folder structure. Inside JuzzRCats is like your main business logic that is going to be overruling everything, whether it's JuzzRCats web or something else. Like, I don't know, a Node.js application. No, that doesn't work. Another Phoenix application that does something else. I don't know. That is not related to the web. So you have all your business logic here. Or maybe another entirely new web application or something that is like completely living outside, and you want to separate that. Couldn't really think of anything what that would be, but here is basically your business logic that can be spread around projects. You know, this is like your core business. If JuzzRCats were to be a business, this is where you put all your important logic. On the web, you obviously group up all the web-related logic. So if you have a website, you just put all the websites and all the URLs and the pages that you're building and all that shit using that other stuff. So an example, if we go to my website, JuzzRCats.com. Oh wow, it actually doesn't redirect to the HTTPS version. That's something I have to fix. But we have a playlist section where it shows what the current playlist is. I haven't updated in a very long time. I have a dashboard for this, but playlist for JuzzRCats is kind of its own domain. You know, it's its own business logic that you can do with. You can create playlists, you can update playlists, you can set a current playlist. All that stuff is pretty important. So in JizraCats, we have a playlist domain where we can say, if we want to list all the playlists, you can call this and it will get you all the playlists. Or you can get a specific playlist. You can create a playlist, you can update a playlist, you can delete a playlist, etc. So that's basically inside of JizraCats domain, which means that across projects, I can basically update or delete or whatever the hell I want to do with playlists. The idea for this is that we're gonna migrate all these parts of our website to this new platform because it gives us more features. It's faster. And it doesn't take as much memory as my current website does. So it's a lot more performant. And I think, which is also really a good benefit, is the fact that my current website, if I have to make an update, my actual website goes down. So if I were to make a new version and I make some new code and I add an extra app or something, my entire website goes down for a couple seconds and then it boots back up, which is just not acceptable in 2019. This is ridiculous. You should not have this currently when it's 2019. If you have a website, it should at least like do your thing. You know, it should like, whenever you push code, it should make a new version and it should slowly gradually move towards that new application without going down. You don't want to be down in 2019. That's just unacceptable. So what we're going to do is we're going to slowly move away. I think we already set up something. So I think we already have set up like a playlist thing where we can create playlists. So I can create a new playlist, Bob Ross's playlist. Really cool. It's an awesome playlist that goes to google.com. Awesome. So you can go to a playlist. We can see the list of playlists right here. We can delete the playlist. We can edit them. We can show them. All nice and dandy. So pretty much exactly what you would want to do here. The thing is, though, is obviously when somebody goes to my website, you don't want everybody to make playlists. What a surprise! Whoa. What's up, Journey? How's it going? What's up, Peef? You don't want everybody to come in here and just create a bunch of playlists, right? That's like unacceptable. That's just not how we do things here at JizraCats. So what we want to do instead is, instead of having this just out in the open where everybody can just go to /playlist and create one, we want to be able to only show the playlists to the outside world, and creating is going to be part of the admin panel. So if I go to my admin panel here, you can see that I have to sign in first, and I think I can just sign in real quick. Let me just do that. JizraCats.com. Sure, I think it's this one. Hope so, at least. We're doing it live, boys. We're doing it live. Boom. Okay, we're logged in. So here you can see that I can manage all my playlists. And if I update, for example, I'm listening to this one now, I can go to this one and it will show up that we're currently listening to Purple is Hot, best of the best playlist. Which is cool, you know, it's neat. It's neat that we're able to do this. But we need this admin panel and we need to be able to log in. So what we're gonna do today is we're gonna build an actual authentication system. So a system where we can log in and only do a bunch of stuff when you're logged in. So we don't want to go to the admin panel and just go and change stuff. I don't want you guys to fiddle around with my playlist. So let's try and build it. So, because what I said earlier, all the non-web related stuff should be living inside of or outside of the web part. We should probably build this authentication kind of related logic inside JizraCats. So next to playlists, we're probably gonna have something like authentication and like users or something like that. That just explains that you can have an account, you can have a password, and if you fill in your username and password, you're logged in, and we can show you a page that you're normally not supposed to see. I haven't done this in a while, so I probably have to Google. But let's take a look at how this should work. If only I knew how to do this, or like what the proper things were. I've done this like I think 2 times already on stream, but I can't remember how it goes. So I think we need I don't think we need Guardian. I think we can do comeonin and Bcrypt Elixir, or I think that's already in comeonin. So for those of you that don't know, if you're building something, if you're building an application, you're not going to build everything from the get-go. You know, you use someone else's parts of someone else's code that is open source, which means that everybody can look at the source code and understand what is happening. So you know what you're pulling in is actually not like a virus or like anything malicious that you don't want to have in your application. So in theory, we could look at this and be like, okay, let me make sure that I'm not going to get hacked when I pull this in to an application. It's just a plug and play system, you know, like you take someone else's code, you have to make sure that that's good before using it in your app. We know that comeonin is actually a very an often used thing in Elixir, so I'm completely fine with using this. I'm re-googling it just to make sure that I have the right one. But this is a library that's well updated and is used quite a bit. And I've seen this, like, I remember last time when we built an authentication system, this is the way to do it. Have you ever straightened your hair? I have actually, yes. So, what comeonin is, I think. Let me see. Comeonin wiki. Comeonin is a specification for password hashing libraries. Okay, so what this thing does is, before we move on, let's just explain a little bit what authentication is and what we're going to be building. So a user, which is just you, is going to /admin or something like that, or /login or whatever the fuck. He's gonna see the login page, and he's gonna be able to fill in his username and his password, or his email and his password, whatever, right? So it's like a box where you can fill in your username and your email and your password, and a send button, login button, right? Something like this is gonna be the UI. And in order to have an account in the first place, you will need something like a register system. Well, I mean, we're gonna make an account that is, you're not gonna make it through registering an account, but let's just, for the sake of it, let's just make a register page as well. So this is a login page. Woo, login, yay, okay, cool. But we also need a register page. So if you were to like have any website, you would just register your account by probably having an email and maybe a first name, or like your name in general is probably good enough. Oops. Your name is probably good enough. Nice. This is like your typical registration form, right? And probably like a password confirmation. You know, that's like, this is like your common like flow, right? Flow of account creation. You just have to fill in your name, your email, your password, and confirm your password, right? That's like a common flow. So what this does is whenever you hit register, we're sending all your credentials to the server. So we're sending your credentials to my application, right? And I could do whatever the fuck I want with those credentials, but most people would just save it, right? So what we could do, which is something you should never do, but let's just for the sake of it do it anyways. We take your username and your email and password, and we save it plain text into the database. So we have this database right here. It is called Postgres. It's just basically an Excel sheet, spreadsheet. I think I have to be logged into Google. It's basically a spreadsheet of just like a couple of columns and rows, right? Which is really bad. So I have an email and a password, and you would fill in your email address here. Right? This is like your normal spreadsheet that you have, and you fill in your password here. Sick ass password, really secure. Oh my god, what's happening? So this is bad. This is very bad, because what if somebody were to log into my server or like hack the database, and they have access to everything now, which is really bad, right? So if you're doing this, then you should really consider switching jobs. So that's messed up. So everybody's records are in here, like zephyraf3@gmail.com, and his password is obviously Boyd is awesome with 2 exclamation marks. You don't want anybody to like know your credentials, right? That's like a little spooky. So what people do instead, that's actually my email. So what we want people to do instead is we want to take this and we want to save this Bcrypt online. Let's see. Let's encrypt this using Assault. So let's take this password and let's Bcrypt it. And instead of... Oh, what the fuck? Okay, this is not exactly what I was looking for. I need something that has an actual salt. Okay, so string to encrypt. Boyd is awesome. Hash to check. String against. Yeah, so rounds of encryption. Cool. I can hash this string. And I get this string back. Right? And I save this one in the database. So now if the hacker takes this database, all the credentials are like super random things that you don't really know what to do with. Actually, this is also not a very good. Let me see, what was the other one? Argon? Try Argon Online. Argon to online. Yeah, so Salt. Let's use this one. Okay, so I take the password Boyd is awesome exclamation mark. I add some salt, which is the only thing that's the secret that only our application should know, and you should never put this in your code base. You should leave this somewhere where nobody can ever find it. But your application still wants to use it. It's really important that you have salt, because this is the secret that we're going to encrypt your password with that a hacker should never know about. So let's put the salt like a 1 2 3 4 5. It's a really shitty salt, but sure. How do I apply this? Enter. Salt is too short. Damn it. Okay, enter. So we got our beautiful encoded password here, I think. Or is this the encoded password? Maybe this is the encoded password. I don't really know how this works. Anyways, so let's pretend that this is the password. So, whoa, we got a new password. So if the hacker gets this, he can never like decrypt this because he does not have this salt that we filled in. So he does not have the actual key in order to decrypt this password. So he has basically useless data. If he steals this database, he cannot actually get the actual password because he doesn't have the secret key that we encrypted this password with, which is fantastic. If we were to store this exactly next to the password, he can obviously do whatever. So it is important that you encrypt your passwords because people will not be able to get your password. So, but how, if we log in, how can we guarantee that this is that person? Because the person is gonna obviously send a password like Bob Ross 123, and it's gonna send it, but it doesn't match with this password, right? So if we were to not encrypt this password, right? If we go with this example right here and not encrypt the password at all, the user would log in and send this email. It would be like, email is this one, and it would send this one. And then we would check, hey, do we have any records where this email is this one, and this one is the password? And then the database would say, yes, I found one. And now I know that you logged in, right? That's perfect. That's great. So now I know that I logged in because I found someone with that email and I found someone with that password, and both of them are matching, right? I found a record where the email address is this and the password is this. I found exactly one row. If I fill in the wrong password, Bob Ross 123, but the password is ASDF 12345 1234, it would never find this record because it would search for an email and a password, but this record only has the same email but doesn't have the same password. So it would say, nope, could not find anything. And I'm like, shit, okay. But that's great and all, but we should never actually plain text our passwords, right? So let's go back to this example. If we were to have this, we're like, well, shit, you know? Well, shit. That is kind of crap. So we cannot, we send Bob Ross 123, but we will never find a user, even if the password is correct. So even if the password is Boyd is awesome, you would never find a user where this is the email and this is the password, right? So we'll have to do some extra magic in order to get this done. But if you think about it, in order to get this, in order for us to save this password and get this value, we encrypted it, right? So what if we take the password you fill in and we encrypt it with the same salt? That means that the hash is always the same. That basically means we transform it into this one, and then we can check, hey, the encrypted password, is it the same as the one? So now I'm asking, hey, database, do you have someone for this email address and this password? And then the database says, yes, I found one. If the password is wrong, however, so let's say I do Boyd is awesome, but it's like Bob Ross 123 with the same salt, we would get a completely different hash. It's not even that different, but it's definitely different. So it starts with 5.0, but we're already 5.3, 5.6, blah, 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 blah. It's completely different. So then the database would say, hey, you're sending me this user and this is the email and this is the password, but I cannot find any records. I cannot find anyone that matches that. 0 results. So now we know that this user has filled in either a wrong email or a wrong password, right? That's what we know. That's great. That's cool. So this is what we're gonna build. We're gonna build a form that we're gonna send, and then we're gonna say whenever we register, we're gonna save the user, we're gonna encrypt the password, store it in the database, and then whenever you try to log in, we're gonna send the credentials, we're gonna encrypt the password again, and then we're gonna match and see if we find someone's credentials, and we can basically guarantee that if we found someone, we can log you in. And then set a cookie, which is what I'm gonna explain later. It's up there. Hope this is clear to everybody. Hope so. I hope we're onto something here. Beautiful. Okay, that's cool. That's perfect. So now we securely stored data that we can retrieve later on. Or we don't even have to know what this password is. We literally don't care what this value is at all. All we care about is that when we log in, that we match the passwords. So we re-encrypt it, we take this password that you send us, we convert it with the same salt plus this string, and then we're gonna say, do some awesome encryption with this, and then the outcoming results should be this one. That's what we're checking. Is whatever comes out of this the same as this? Then I can say yes. Okay, let's just get in. That's what we're gonna do. Wait, so how do you code it that the system turns the password into encrypted version? So that is exactly what this library does. There's a ton of different encryption libraries, and there's 3 that are included in this library. There's Argon2, Bcrypt, and PBKDF2. If you ever come across MD5, don't ever use this. This used to be the standard, but this is really easily hackable. So, or not hackable, but it's like easily decryptable. So if I put a string here, Bob Ross, and I MD5 hash this, it's like, okay, I get an MD5 hash. But the thing is, there's so many, for the computer to decrypt MD5, it's not that slow. So MD5 decryption. So, and there's already a database with over 800,229 or 829,726 billion cracked MD5 hashes. So probably somewhere you will find your own password in here. Yeah, so don't use this. This is outdated. This is not the best way to encrypt anymore. And I think SHA-1 or SHA-1 is already, or even SHA-5 I think is already, like, Google already thrown so many computers at that it's also not that great. But Bcrypt is very well known, and Argon 2 is the newer one, I think. That's like the fastest or like the best one right now. But the most important thing is that you just encrypt your password. You encrypt the password before saving it in a database. I don't want to see any of you guys go into production, save a password in the database that is not encrypted. All right. What's up, Katie? How's it going? So let's do this. I can't remember how we can add. Oops. I cannot remember how we actually have to add libraries, because I haven't done it in a while. I haven't touched Elixir in a while, actually. Yeah, let's see. So, let's install this baby. So let's go to the Hex. Hex is basically the plug and play manager of Elixir. So with Hex, you can install other people's code into your application. So what we're gonna do is we're gonna just go to mix.ex, which is outside here. And you can see that we're already using a couple of libraries: Phoenix, Phoenix PubSub, Phoenix Ecto, Postgres, Phoenix HTML, Phoenix Live Reload, GetText, and Cowboy. So we're gonna add another one. We're gonna add comeonin 51. Save. Okay, now we need to do mix, I think. Oh, did we fuck something up? Oh yeah, we're missing a comma here. Perfect. Mix. Mix deps get. Beautiful. All right, so now it says these are all unchanged. We didn't change any of those. We added a new library, comeonin 5.1. Awesome. Perfect. Perfect. So we've added this library now. We can access it within our code. Beautiful. So what we're then going to look into is Phoenix contexts and how we can generate one of those. So I'm using a framework called Phoenix, which I spoke about earlier, which is just a web framework. I can just build shit within this framework. It sets up a bunch of files already in like an entire structure to work with, which is great because you want to be fast and you want to build stuff, right? That's like the most important thing. We want to ship things. Within Phoenix, there is something called context, which basically tells you like, we're going to be building this feature, right? We're going to be building authentication, and we want to build files, or we want to make files and modules within that, the domain called authentication. So everything that's related to authentication is going to live inside that folder, and we call it context, basically. So for example, they're creating an accounts context, which is exactly what we're going to do. Because we were going to manage accounts. That's like the domain. Account management is going to live there. So we're going to be able to create users and authenticate them and all that shit. So let's do that. So let's follow exactly what they're doing. So we need a... He explained the idea behind auth. I just did it. If you go and watch this stream back, see, we literally just explained what it is. But it's basically just login. We're just going to build login. But welcome, Weelu. How's it going? What's up, Kasha? How's it going? So we're going to build context basically for this, and you're able to generate this actually. So let's do that. Let me make sure that my database is in the right shape. Elixir comeonin requires Elixir 1.7, and we're on Elixir 1.6.5. Oof. Okay, whatever. We'll see if it's actually running into errors, but we'll see that later. So we're gonna generate a resource or context. So we're gonna say we're gonna make an accounts context. So this lives in the accounts domain, and the model that we're calling it is gonna be user. So we're gonna have users, and it's the table name is called users, and then it's gonna be name is a string. Let's call this email as a string. We don't need username, but this needs to be unique. I don't care about the name really. We can add that later. So we have an email, and we want a password. But apparently they're doing the password later, which is fine. I'm gonna add the password though, which is a string. And yeah, that's exactly what we need. That should be good. All right, let's run this. Generate it. What's up, Connor? How's it going? I want to learn Elixir, but the syntax looks kind of weird. Really? I'm used to things like Go and Java and stuff. Ah, I see. I see. Yeah, that is super different. It is a little weird if you come from that area. A lot less curly braces. A lot less curly braces. Okay, so we're gonna add this to our. So it basically already generated a bunch of stuff for us. It generated a controller. It generated a bunch of templates that we can create users with. It generated a view, controller, tests, and all that shit, which is great. It created an accounts context here, inside here, and it created this like beautiful file that we had before for playlists as well. This is basically get a list of users. We probably won't need any of this, but it's nice to have. It's nice to have, I would say. So let's just work with this resource, right? So let's add this. We basically have to tell our web server. Let's start the web server. Let's first run this. So in our router, we can basically tell, okay, if we go to /users, let the user controller take over. That's basically what we're saying here. So let's add this, and let's mix ecto migrate, which basically creates this thing in the database. Think about it as like your Excel sheet. We're just making a new Excel sheet especially made for users. That's what we're doing. That's all we're doing here. Beautiful. Okay, so if we were to go to our website and we start the server, so it's mix Phoenix server, we should be able to go to /users, and we're gonna be able to have a list of users. Okay, let's create one. Bob Ross at bobross.com. Password is 12345 Save it. We just saved a password plain text in the database, but that's fine. That is okay. That is completely fine. That's sure, man. That's okay. I don't mind it too much. Okay, so in order for us to ship the code that we have this little thing here. Can I make this bigger? Oh, I can actually make it bigger. Perfect. I didn't even know that they had that. So I have this little application here, which is just managing my Git. Git is basically just version control, telling me that I've changed a bunch of stuff and that I want to save it. Pretty much all we do. It feels like there's something underneath there, but it's not. We're gonna make a new branch. Call it live authentication. We're building this. It already built a bunch of tests. I literally don't care about these tests because I think they're not good tests because we're not gonna have any of this anyways. But sure, let's just keep it for now and just whatever. So generate a bunch of stuff, and we're gonna say, okay, bootstrap account resource, because that's exactly what we did, which is perfect. So we basically, whatever we just generated, we just parked it. We said, okay, take a snapshot of the code right now. This is the state that we're currently in, so we can roll back whenever we made a mistake, which is good. Okay, so we just made a user, and as you can see here, it shows the database. It says insert into the users table. So into Excel, you see this Excel sheet. It's for users. It's called users. And for email and password, and inserted that and updated that, enter these values. Bob Ross is the email. 1, 2, 3, 4, 5, 6 is the password. Don't ever do this, but it's fine for now. Don't ever save your passwords plain text in the database, but it's okay. Okay, so next up, we're gonna make an authentication, an auth kind of like context within our application, because we don't want our users to know about login. Our user is just for saving. But our account should also should kind of know about it, I think. But we can at least have, let's delete all these methods or comment them out. I don't really know what we're gonna do with them, but maybe some of them will be useful. So what we kind of need is, if we look back at the flow, we will have a bunch of credentials, and then we're gonna ask another service that could maybe live in accounts. I don't know where I'm gonna put it yet. We're gonna ask that library to just encrypt the password for us. So let's just quick and dirty build it first, and then we'll figure out what we're gonna do later. So let's just build it. It's really hard to do things right from the start, if I'm completely honest. What's up, Unseen RNG? Thanks so much for the follow as well. Also, there was someone else. QDog X13. Thanks so much for the follow as well. So let's make a function that is called create user, or yeah, sure. So create user is already something we have here, so let's steal that. Create user, which it takes a user model, adds a bunch of attributes that we send over, and then inserts it. We don't want this. We want to encrypt the password first before we do this, right? So, let's think this through. If we're sending the password, do we want to do this on model level? So validate the required fields, check uniqueness, and then encrypt password. Is that something we want to do? Maybe. I'm thinking if this is the right way to do it, or do it within the service, so to speak. Make the service responsible. I think it is not bad to put it on model level and just before save, make sure that we encrypt the password. But I think this will be used for every single one. And I don't want to encrypt the password every time. I only want to encrypt the password whenever I only want to encrypt the password if we actually changed it. But sure, let's just put it in the service first and then we'll figure it out. So let's do it quick and dirty, right? Create user, blah, 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 school, no. Sure. Whatever. Has one credential. Alias accounts credential. Before we integrate credentials into the web layer, we need to let our context know how to associate users and credentials. Oh, they're talking about a join table. Yeah, so they have a separate table for the email or something. So they have first name and then they have credentials separately. Sure, we're not gonna do this. Oh, here, authenticate by email password, which is cool. Sure, this is a session controller. This is for web, that makes sense. Yep. Authenticate user, blah, blah, blah. Okay, let's first just make sure that we encrypt everything. So we have our comeonin, and let's take a look at how this works. How do we use Argon? Docs. Argon. Add hash. Takes a password as input and returns a map containing the password hash. Check the password. So, oh, this thing already has a bunch of helpers, which is perfect. That's great. So we can do Argon 2. Verify the password. We can make an abstraction on top of this if we really want to. Have our own like authentication kind of thing that can do exactly this, that uses Argon. Might not be a very bad idea, but let's just first do it quick and dirty and then figure it out. So they do account get by. Oh, what happened? Oh, okay. My screen just went completely back. Verify user, blah, blah, blah. Cool. The length of the random salt. How does it check the password? Wait. Where does it get the salt from? The hash. The hash key. So you add an hash. I'll take options that are then passed to the hash password. All right, let's just try it, you know? I just don't want to stay too long into reading and doing it properly. I just want to do it quick and dirty and just hack it in and then figure out as we go. All right? So put password hash. We put the password. So private function, put password hash. It takes an ecto change set. If it's valid, changes password, change set, Argon at hash password. Aha. So this thing will actually have a password hash on the so it adds a password hash on the chain set, and then you store this on a user. Where's the initial secret then? I don't understand where that's put. I'm really confused. All right, let's just Google this. I'm missing out on something. Come on in. Elixir. Let's just read. I think in the end we actually have to read. Shit, man. I just wanted to build it. All right. Phoenix Authentication to do application part 2. Beautiful. Okay, so we have a user chain set, and then we say, okay, for the user, Yep. Could not render, blah, blah, blah. Cool. We don't care about this. We already scaffolded this. All right, here. So we have a user. Oh yeah, we can actually go to the database and see. So if we do IEX, we got an interactive shell, and then we can do alias, and then we can say jizracats dot accounts, I think. And I think our module was called JuzzRoCats accounts user. So we can now do accounts.user. Okay, let's do an alias for that too. Alias JuzzRoCats accounts user. Okay, so now we can use user. And we can do repo.get. Oh, we need the repo itself. Wait, what? Alias JuzzRoCats.repo. Sure. So we can do repo.get, and then we can put in the user and then the ID of 1. Get is unavailable. Wait, what? JuzzRoCats repo, yeah, here. What the heck? Repo all. Oh, we have to do repo. No, wait, huh? Get with a bang? Repo is undefined. JuzzRoCats repo get is undefined, not available. But we're using it right here. Repo. JuzzRoCats.repo. What the hell? I'm so confused. Oh, maybe we need to import this? No. I'm really confused. How is this not working? Repo is here. Get? There's no get. If I put in a user... User ID, yeah, here. If I then say user 1... Alright, what about repo all user? Repo all is undefined. Okay, I'm really confused. Ugh, how is this not working? Oh, I think I have to do mix something. If we enter IEX. Mix, Phoenix, console, I don't know. I'm really confused. Oh, do I need to do this? So I have all the okay, here we go. There we go. So now I can run JuzzRoCats.repo.all and then JuzzRoCats.accounts.user, and then I get all the users. All right, beautiful. There we go. Okay. Whew. Okay, we're back. So I have to just run an initial one. Okay, so if I ask the database, hey, can you give me all the users? I get a user back. I get a list of users. What is the IEX mix that you just did? It is basically telling you IEX is an interactive thing that you can run that runs with the language, that comes with the language, and an smix basically tells you that it also should include all the dependencies, so all the plugins that I downloaded. Remember how I added all these plugins here? So just telling you, hey, go into this interactive mode and also load in all these plugins that you've added, all these dependencies. And then I can basically say alias, what I did before, JuzzRoCats.accounts.user, alias JuzzRoCats.repo. So I don't have to constantly type JuzzRoCats.repo. I can now also just do repo. And I will get the same thing. So I'm aliasing user to be this entire module. So we can do user or repo.get user 1, and this will get me the user with the ID of 1. So that's good. So if I were to get repo.get and let me see how I can add options to it, because I want to actually have a query that searches for a bunch of stuff, right? Get by, so I can do repo get by user, and then I want to say email equals bobross@bobross.com. This is basically the code that we have to write ourselves later. Password, and then 1 2 3 4 5 6, right? And we found the user. So if our password is wrong, see, you get nothing. You get like, oh, couldn't find anything. We found nil, which basically means nothing. This is basically what we're doing. So I just asked, hey, hey, repository, which handles all the database stuff, can you get by? So hey, can you get something which I'm passing to user? So I'm saying, hey, can you search inside users for something where email address is equal to this and password is equal to this? And then the repository is like, okay, search, I gotta do this. Let me ask the database. So it hits the database and it asks, select ID, email, blah, 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 all the fields from the users table. So from the user Excel sheet, where email address is equal to bobross@bobross.com and password equals to 1 2 3 4 5 6 7. And then the database said, I didn't have anything. And you're like, okay, fuck. But if I do fill in the right password, the database returns me, hey, I found one record and you only asked for one. So here you go. This is what you got. You got your beautiful email and password, which means that I can log you in now. Beautiful. But instead of, oh, okay, so they called it in the database, or in comeonin, they use password hash, but we call it the field password, which I'm fine with. I don't care. And I'm pretty sure we can just map that. I don't think that's a problem. So here, inside of models, they put it inside web. Okay, I think that's an old thing. But we can definitely put it inside the change set. I'm fine with that. I'm completely fine with that. But I do think, yeah. So you can normally have this function called put password hash. Oh, okay, so you made a private one. Okay, so let's do that. Let's just do it in here. If the tutorial says it, you have a normal def and you have a def p, which basically means that it's private. So you're basically telling this file, hey, you can only use this function inside this file. You cannot use it outside. So let's call this encrypt password, because that's what this function does. And what it takes is a change set, and then what we are gonna do is we're gonna so he made a case statement saying, like, if it is this one. Oh, that's actually a good point. Okay, so that's exactly what I was talking about. Cool. So he basically made a case statement, which basically says if there's a couple of cases that you need to handle, do something. For change set. So we're gonna look at the change set that we pass, and then we're gonna do a bunch of cases. If there's something that we don't handle, you use an underscore, so there's like anything. We just return the change set. That's what we're doing. But if the change set is valid, so what we're doing here, to give a little bit of context, we can only change a user using a change set here. We can only change a user if it goes through these actual steps, right? So we basically tell, okay, you're gonna get me a user, and then I'm gonna first check a couple things. Before we can save in a database, before we can save you, we're just gonna do a couple of things before we're gonna save it in the database, right? We need to do a couple things. First, we need to cast our attributes. So whatever you're sending, is this lower casting? Is that what it is? Cast. According to the given set of keys, return change set. The given data may be either a chain set, schema, or structure. During cast, all permitted parameters will have their key name converted to an atom. Okay, so you're basically telling whatever you're sending to me, I can only accept these properties. So let's say you can never change the password. You would remove it from here. Because if you're using this application, we would never allow somebody to change the password, ever. That's just given. You can never send me a password or anything else. So if they're sending us other stuff that we're not permitting, we're just gonna take that and just remove it. If you're sending, let's say attributes is something like this. It's I don't exactly know how Elixir works that well. Let's say email is some awesome property here, which is blah, right? So I'm sending this. So I'm sending an awesome property blah. Then what this step will do is it will just strip this off. It will just be like, nope, I don't know this one. Let's just get rid of it. So it passed that first test. We're sending email and password, and these values are present. So it's going to be like, okay, sure, these are allowed to pass true. So that means that we're going to the next step, which is validate required, which is just going to check, hey, did you send in the required fields? Or are the required fields on this user set right now? What's up, Ani? How's it going? You're an actual dev? Yeah, I'm an actual dev. So what we're saying is we need to check before we save anything in the database. We need to check that that we have an email and that we have a password set. If we do not have these set, we cannot save your user. All right. Third check is we're gonna check if the email address is not already in use. You know, is this email address already saved in the database somewhere? Then we should also fail. So these are just validations that we're gonna do. And then the other one, where we're, the next one that we're gonna pass is encrypt password. So it takes this user change set and accepts this as a first as its first thing. So basically what this is like, it is pretty much this. This is what it's doing. But in order to make it more readable, we just do it like this. So that whatever comes out of this so far is passed to the next one. That's basically what it is. You're piping through whatever it is. I don't know. Is there paint online? Yes, perfect. So if you were to have a couple boxes, can I make this bigger? Beautiful. Paint online, guys. What an invention. If I have a box, then I pass it through this black hole right here, and it does something with that box, and then it goes out and it does something. So now the box is red, right? So this magical portal made the box red, right? Beautiful. Yeah, beautiful. Okay, it goes into the next portal, which does something, and we tell it exactly what it obviously does, which makes the box bigger. A bigger box, but it's still red. Right? Fuck. Oh god, Windows is so shit. I have Windows. I like Windows. It's fine. Okay, so we have a couple transformations here, and if you look at the code, this could be something like this. It would take a box, and we would pipe it through a couple things. Let's set the language to Elixir. We take the box and we put it through a lot of things, like make red. And make red would be something like this. Make red, which takes a box. And then, I don't know, box set color red or something. I don't know. I don't exactly know what it actually would do, obviously, but this could be something that it could do. And then we also pass it true, make bigger. So you could write this like this, right? Make bigger, make red, box. You could read it. You can also write it like this, but that's not very readable. So you basically have to read this from the inside out, right? It's like you take a box and then you call make red on it, right? So we make the box red. So this returns as a new box, which is now red. And then we pass that to the next one, which is make bigger, which also takes a box. And then maybe there's another one called flip box. And then so we take this, we call this, and then we return another box. And then that's a lot of work, and it's not very readable. So what we want to do instead is we want to have this nice and readable. So we just pipe it. We just pipe it. We take the box, we pipe it through make red. If this is done, it passes it on to the next person, which is going to make it bigger. And then the next one is going to flip the box. Right? That's exactly what we're doing. So what we're doing is we validate all this stuff. And every single one of these is going to return me the user change set. And it might have changed some validation rules, right? It's maybe said, maybe it failed here. Maybe it failed in uniqueness constrained email. And it was like, yeah, this email is already in use. So valid comes in and it's false, right? So this change set that we're having here looks like this, right? It looks like this. And there were pattern matching, which is really powerful. I don't know what put changes. We'll look into that a little bit. Let me just finish this real quick. Okay, so what we're doing here is basically an if statement. If you guys have ever seen if statement, it's like if the change set kind of looks like this, do the change, right? So we can say make the change, set password to be the encrypted version of the password that we're passing, right? Else, I don't know the syntax in Elixir that well. We just return the change set because it was already like invalid, or you didn't change the password or whatever. So we don't want to make any changes to it. If it was invalid, we'll just keep it invalid. That's fine. That's all right. But this case statement is a little bit more powerful because it's pattern matching. So if this change set matches with this pattern, that is valid is true, and changes equal that there's a password in there somewhere. We don't know the value of it, but the changes contain the password. So you have changed the password, and then we're telling password, let's call that pass. Yeah. We can also make it password if we really want. We can just make, which basically turns it into a variable. So whatever comes out of this, we take it and we store it into this variable called password. And then we run the code that is inside this arrow. After this arrow, it's the block that we call, and we say, okay, make a change to this change set for the field password and change it to whatever comes out of here. So we take the comeonin library, we go to Bcrypt, and we hash the password salt with the password. All right. Beautiful. If the change set is incorrect, the first pattern won't match, and the case structure moves to the next pattern. Beautiful. Okay. So let's see if this works. So if I were to go to the command line here, I'm not sure if I have to restart or reload. How do I reload the thing? I think I can reload or like re-import or something like that. Phoenix or Elixir reload IX. So ix as mx. Cool, cool. Beautiful, beautiful. This module gets recompiled. I thought you could just say reload everything. Also, let me make sure that my laptop doesn't get too warm. Fan. Because my laptop always gets super hot. Alright, there we go. Can I reload or something? Please? Alright, let's first see if this works. What if I just reload user? Should be good enough. Redefining module, currently... Beautiful. Okay, reloaded the user module. Perfect. That's exactly what we wanted. Okay, so if we were to repo.create, I think that's what it is. Let me check the accounts here. Create user, and we need a user, and then we need a user chain set, and then we insert, but I don't want to insert yet. Let's just steal this function right here. Oh shit, it has comments in it. Hold up. Def create user. Let's just copy this first line by line. This one. And it takes this one. And then you pipe it through this one. And then you pipe it through this one. And then we end. End. Oh, okay, we already ended. Okay, so I can create a user now by giving it a couple properties. So I have to pass in an email, and if I only send in the email, undefined function, but I just created it here. What the heck? That's weird. Def hello to. How do I puts? Is it puts? No, I think it's print. Print Elixir. I can't remember how to print. IO puts. IO puts hello world. Enter end. Def outside of module. Oh, god damn it. Okay, sure. Module. Bob Ross. Do. Def create user. Let's just copy this again. User. Chain set. Repo. End. Undefined function module. God damn it. Okay, how do you define it? Oh, I think it's def module. God damn it. Okay, here we go. One last time. Def module. I'm not using enough Elixir, guys. You can already tell. User, chain set, insert, end. Beautiful. Okay, now I can do Bob Ross dot create user, and then I can pass email is ross@bob.com. Oh, I gotta expect params to be a map. Oh, it needs to be this. I can't remember the syntax, man. All right, here we go. Okay, so as you can see, it tried to insert it. So we asked the repo in this function, right? We asked, okay, create a empty user, then pipe it through the change set. So take this user empty thing, give it a bunch of attributes that we passed. So we passed it. Email is Bob Ross, ross@bob.com. That's great. And then try and insert it. Just straight up send it to the database. But we called this user.changeSet. Remember what we did in this user.changeSet? Here. We call user change set. It passes the user and then a bunch of attributes. See? So what we did is the user is this one, and we pipe it. So the first argument is going to be this. Second argument is going to be the attributes that we sent, which is in this case this. And then we map it. We cast it through everything here. So we cast it. We validate if it's required. And here is probably where it broke, because we didn't send a password. See? So we got an error. It added an is valid false. And we got an error on there. So it says can't be blank. Validation is required. Beautiful. But you can also see that the changes to this change set were email set to this. So if it were to actually go to encrypt password, it would check if this is pattern matching with this change set. So it's going to check, okay, valid true, valid false. So it already said, okay, this case is not matching. I'm going to pass. But if this were to be false, so like, okay, valid is false. I'm matching right now. I'm matching, but there's another thing I have to match on, which is changes. So I'm going to check if the changes contain a hash password. So I'm checking, okay. A map. This is called a map. A map password. Oh, it doesn't have any key called password. The map doesn't even have a password symbol thing. Oh, so it doesn't match it again. So let's make a correct one. So let's add the password. And then we say, hello, my password is 1234567 as a string. And now it should be valid. But let's first, before we do this, let's let's repo.get user, or all, sorry. I want to get all the users again. Oh shit, what did I do? Oh shit, what did I do? Do I have repo here? Yeah, repo.all user. Okay, so we had already this email. So let's try again, creating a user that already has this email, right? So instead of this email, I want to have a different email. So we have all the fields, so it's passing that. Oh, it's missing an ending parenthesis here. Okay. Let's try and make a... Oh shit. Comeonin Bcrypt hash pass has been removed. Add to your mix file. God damn it. Okay, let's do that. So comeonin is not the actual hashing library. It's just a bunch of helper functions that you can use to like hash password and all that shit. Okay, fair. So in theory, do we even need comeonin? I don't know if we need comeonin because all we're using is Bcrypt right now. Okay, so let's just add this one. Sure. Bcrypt Elixir. Fine. Let's exit this. Let's mix depth get or something. Mix depths get. All right. Beautiful. Says it added two new libs. It added Bcrypt Elixir and Elixir make, which is probably a peer dependency. Sure, fine, whatever. Let's continue. So instead of this, we just use Bcrypt directly, Bcrypt Elixir. See how that works. Come on wiki. How do I use this? It says I must have C. Alright, whatever. Where's the docs? Preferences. No, algorithms. Add hash. Check pass. Same as comeonin Bcrypt check pass. Takes a user struct and password Struct and password is input and verifies the password. I don't understand what comeonin does then. What does comeonin even do? If it doesn't do the encryption, what does it do? What does it do? Password hashing specification for the blah blah blah. Okay. Specification for password hashing libraries. Let's just try it. Fuck it. You know? Whatever. Load. Dependency Bcrypt. Elixir requires Elixir. Something something. Cool. Whatever. Oh shit, we don't have this function anymore. Okay, let's steal it. Let's steal it again. I don't want to write this again, so I'm just gonna steal it from here. Module, def module, Bob, Ross, do, and I don't care about the formatting. Cannot expand struct user. Where is the science and technology? Sub Lars, how's it going? Thanks so much for the 38 centuries. Welcome back to the cats community. Oh my god. This is science and technology, man. Okay, I forgot to alias just draw cats repo. Alias just draw cats dot accounts dot user. Now I can actually make this function. There we go. So we have Bob Ross. We can on Bob Ross, we can now create user. Create user, and it takes attributes. So email is equal to, what was that email that we had before? Repo get for all user. This was the email. So if we now do user Bob Ross dot create user with this email address. That's a good password. Thanks, man. And password doesn't really matter because it will complain anyways that we cannot create the user. God damn it. What the fuck? I thought I changed it. Oh, I forgot to save it. User. Oh, it doesn't have, they changed the password. So, okay, sure. Hash, whatever. Okay, they changed the syntax a little bit since the last version. Whatever. Sure, let's reload. Okay, so like I said, it would error out because we had a validation that was gonna check, hey, is this email actually unique? How did it actually encrypt the password though, is what I'm wondering. Because valid is true and changes his password, but this is not actually valid. Did it reach this code? How is it already encrypted? I don't get it. That's actually really fucking strange. So it actually hit this line. That is very weird. Because this change set. What? This change set is not actually matching at all. Ecto change set. Action changes email blah blah blah. Errors. Valid true. How is it valid? If the uniqueness... Okay, I get it. I know why. I know why it passed. Uniqueness constrained is something you can only check after when you hit the database. That makes sense. So it's nice and all that I'm having this before. But uniqueness constraint, you can only know if this email address has been used before if you want to save it in a database, and it just tells you, hey, there's already an email address with this thing, right? So we can only change it basically to check this after we save. So in theory, we could actually do this afterwards. Yo, Haster, welcome back to the Cats Minute for 39 centuries. Thanks so much for the resub, man. Welcome back. It's funny how you're 1 year older than Lars. Are you going to be using JWT tokens? Probably not. Probably just cookies. Encrypted cookies. I don't know, honestly. We're gonna see. We're gonna make things simple first, and we can just make it harder later. Okay, so this makes sense. Sure. Doesn't really matter the order. Uniqueness constraint will be last, so I think this makes a little bit more sense. So just validate what you can do here, and then move on to uniqueness constraint later. Okay. So up until this point, this thing has been valid. So let's encrypt the password before and of the chain set, and then save it. Right? That's what we're gonna do. Why do you call your hash salt function encrypt? I don't know. It made sense to me. But it's true. It's not really encrypting it. It's just hashing it. But that's okay. Makes sense to me. Whatever. It's semantics, man. It's semantics. All right. Whatever works for you. Silver Morris, how's it going? Couldn't care less, honestly. I'll care about it later when I actually have to build it. But first, let's play around, see if we can make it work. All right. So Bob Ross is already in the database. So let's do Bob Ross 2. Password. Boom, boom, boom. It says okay. We saved it in the database, and we now have repo. We now have two users. So after validation passed, we actually saved the user, and it's now in the database. This time around, it actually has a hash password, which is perfect. Beautiful. Okay. That's nice. That's perfect. Let's hack around. And we had all this shit copy pasted or like generated. We literally don't care. Let's make I'm probably gonna move this into a different file soon, but let's first make it work, right? That's the whole point. So if I now were to go into the app where we scaffolded, oh yeah, don't have a list of users anymore. All right, let's just roll this back. Actually, I think we can change everything back in this file. Beautiful. Okay, let's roll this back so that our web application works. We now have a list of users in our interface, which is beautiful. And if I were to change the password to be Bob Ross, it will be... What? What? Oh, I did not import the library, right? I think I need to import it here inside my user. Is that actually a thing? Did I need to do that? I thought it automatically imported everything. All right, let's see if this changes everything. What? I thought if I just used Bcrypt here. Wait, let me see. Really confused. Bcrypt, yeah, Bcrypt module. I thought I could just use this everywhere. I thought I didn't need to import it or whatever. Still completely new to the syntax, guys. Still completely new to the syntax. All right. Are we doing anything special here? Let's restart the server. It might be because of that. We didn't restart the server, so I don't think it has this. I think you need to restart your server whenever you update dependencies. That would make a little bit of sense. All right, so users, go to edit. Ross Bob as the password. We hit save. And you see we don't store our passwords plain text anymore, and whenever we change it, it updated and it rehashed the password. Perfect. All right, beautiful. That's great. That's beautiful. So we're not storing our password plain text anymore. That's perfect. That's exactly where we want to be. So let's get rid of this password and just copy and paste it and resave it. Oh wait, we have to change it because it will check. It will see that it hasn't changed. There you go. Change it back. Oh, beautiful. So we have no passwords in the database anymore that are not encrypted or that are not hashed. Sorry, Lars. I said it. All right. So let's make a in these accounts. Let's make a function at the top. Fuck it. Let's do it. Authenticate with email and password. Super long fucking name. Hell yeah, dude. And it takes I think it takes a change set or like a shit, how do you do that? Like this, right? Is it percentage? Percentage, yes. Okay. Was it? That's percent. Yeah, okay. It takes email as email and password as password. And then we're gonna do you do more backend or front end? I work as a front end developer, but I love doing both. It's just the context switching is not helping at all. All right. Oh, so they in this blog post they actually made a different change set just for username and password, because in theory you should never be able to just we don't have to encrypt the password every time or hash password every time. And if you keep this change set the same, you shouldn't be allowed to send over the password every time and shit like that. But that's okay. I think they already implemented something like all right, they're doing this, blah blah blah. All right, sure. Authentication should be that hard. So what we should do is repo get and then user, or we can make use of this get user actually. Can we? No, this is by ID. What we want is we want to find a user by its email and password, which is exactly what we're gonna do. So get by, did it fail? It can fail, sure, because when it fails, sure, I guess. I think this is something. Okay, so we're gonna get by email is email and password is the bcrypted whatever the fuck other way around sort of thing, right? That's how that works. Check pass, yes. Hashes the fuzzer with a randomly generated salt. Verify password. Takes a user struct and a password as input and verifies the password. Gonna be broke now. I finished my college in like June, May, and I'm 18, only beginner really with front end, but might have scored a job as a developer for a local company called iPop Digital. Any advice for getting better or being in the industry? If you want to be good, the best thing you have to do is to know how to learn. And the best thing is to always have an open mindset. Most important thing. Always have an open mindset. In my opinion, I look at myself and I just always treat it as having a beginner's mindset is always the best, in my opinion. Like, don't be afraid. Don't be afraid to make mistakes. Don't be afraid to look back at your code and be like, okay, well, I fucked up, or like, that's fine, you know? I think it's actually really good to fuck up. And don't be, if anybody ever tells you that it's wrong to fuck up, I think that's wrong. Please fuck up. Please fuck up. Please do. This module's in password hash behaviors providing the following functions. Add hash. Why the fuck do I have comeonin if this shit does exactly this? Whatever. Anyways, verifies the password. No user verifier. Runs the hash function, but always returns false. What? Oh. Every now and then it does this. It's really random. Go for guys when you can't get grill. You know, all the guys are here because they know he's single. What the fuck? Yeah, let's see how this works. Bcrypt dot check pass takes a user. I don't want to. I don't have the user yet. But it takes a struct, right? So I guess just this. Question mark? Is that how I make a struct? Something was, so there was something like this, right? Here. Is this it? Is this what I'm supposed to do? I don't fucking know, dude. I think I'm supposed to send him a user that is actually the user by email.
Everyone, get in here!
Some remorse. Hey, send me something? Oh, I'm too scared to click on the link, man. Please. That's a spooky link. It's a free host called Infinity Free. Don't feel neat. Okay. If you... Yeah, it's whatever. Did he come here with great wisdom? Verifies a password. What does this take then? Password stored hash. Oh, yeah, that's what we need. Password. No, wait. We get the user by email. Is that actually what you do? You get the user by email. And then you... Actually, that's probably what you do, yeah. Alright. So we can just do bcrypt. Do we return it? Bcrypt. The check password. What does it even return? What does this shit return? False. What does that mean? That's random. Okay, let's verify the pass. If this, do, else, I don't fucking know what we're gonna do. Let's just first return true or false. Sure. Yo, Genzoom, thanks so much for the follow. What's up, Rosarino? Good catching a stream of yours again. Been a long time. Thanks, man. Hey. Continue the music, please. Thank you. Okay, I don't honestly know what the fuck we're doing, but that's completely fine. I'm completely fine with this. Okay, so this takes a... Oh, this takes a password. We can use the other one, right? Check pass, user struct, and then a password. That sounds good to me. Sure, let's do this. Let's call it. Okay, let's make it a quick page so we can log in. Templates, user, login.html ex. Let's copy pasta the create or something. Oh shit, it's a form. All right, log in. And it's gonna take a change set, and then it's action, blah blah blah, alert, whatever. Send an email and a password, and we hit submit. And we send it to... Shit. What is this magic? Okay, it's not magic, guys. It's not magic. Okay, so let's create a routes. Let's create a get login. Normally you have a session controller, but I'm just gonna be lazy. I'm just gonna shove it into the user controller real quick. Login action. All right. Let's just be hella lazy, guys. That's exactly what I am. Okay, new login on params do, and it's probably better if I just created a session controller, but it's fine. All right, change set. Do we even need this? Do we really need this? Whatever. Empty struct render login.html. All right, let's see what the fuck happens when we do this. Login breaks because action is not available in the EX template. Oh wait, I see already. So in new, you pass action. What? Assigns. Where does this come from? What the fuck is this? Render form map put assigns, whatever the fuck that is, and then action. Okay, let's change this. Sure, man. Can I see my routes? Abort, mix, Phoenix, routes. Beautiful. Do I have a path for this? User path? User path. Login. All right, beautiful. That's exactly what I was looking for. So login, action. Do I do it like this? I don't know, man. We're gonna see. Login. Does this work? Render to is undefined. User view. Okay, that makes sense. Yep. Okay, that's fine. Views. User view. Is that okay? Oh my god, what is happening? User view is not available. User view. It's right here. The fuck are you talking about? I honestly have no fucking clue what I'm doing. Alright, form for it. It's magic shit, man. I love magic. Hello? What is happening? Oh no, I don't want to open. Okay. Form for Elixir Phoenix. What kind of magic does this do? Show me the money. Routes? Oh, this is just... Oh, you don't need to do add action. Okay. Like this. Like this. Alright, very lekker. Refresh. Still broken. Why is that broken? I spent 7 years in Ruby on Rails. Moving to Elixir was still challenging. Lots of little confusing things, no matter how familiar. Right? It's exactly my feeling, man. It's exactly my feeling. Your feelings are my feelings, bro. Having spent way too much time in Ruby on Rails. Way too much time. Fought so much with the framework. So much. It feels way better set up, honestly, if I'm completely honest. It feels like it is properly set up, like Phoenix, compared to Rails, in my opinion. But it's still a little scary sometimes. Oh, you have to pass con? Oh, you have to pass con. That's why the view is breaking, I think. Hopefully. Yay! Okay, we got a login form. All right, beautiful. Yeah. Can you answer Discord DM after stream so things can be settled? See you tomorrow. All right, catch you later, Toos. See you tomorrow. Yeah, I'll check out the DM. Okay, so this will... Oh shit, we're posting to this too. Okay, so okay, fine, whatever. Can I? Is this convention? Login create on params 2. I want to know if something is. If there are params. Wait, how do I know if this is a post request? Oh, here, like this. If we're sending this to the same... Oh my god, look at this, guys. It's gonna be amazing. It's gonna pattern match, guys. It's gonna pattern match. Oh my god. It's gonna... I think this needs to be above then. Oh my god, we're pattern matching, boys. Woo! Look at us go. Wow. That's hot. Okay. Accounts. Oh, here we go. Look at this, look at this. It's amazing. Does it... Yo, Genzoom, do you know if the order matters or not? Because I use underscore here. So does that mean like, oh, okay, let me first check if there's other cases, or does it matter if it's like... Is it dependent on the order? Probably is. Accounts, let's do it, let's do it, let's do it, let's do it. Where does this come from? Oh, this I just named this user. Okay, that's fine. Sure. So it takes out user from the params, and then I put it in user params. Beautiful. The order is important to avoid recursive issues, but only in cases for your catch-all. Right. Okay, let's call the function. Oh my god, this is gonna be a magical moment, guys. We made the most hacky authentication ever in the world, but that is completely fine because we are hackers. Okay, I hope I get okay user back. If so, I'm just gonna redirect you back to whatever. You are logged in. Even though you're not logged in, because we're not setting a cookie at all. And we're gonna redirect you to the show of the user. We're just gonna do exactly the same thing. Otherwise, go back. Let's see what the fuck's gonna happen. So I can't even remember our password. But I think it was bobross@bobross.com. And then 1, 2, 3, 4, 5, 6. No post found. Ah, shit. Rip. Oh, that's right. That's right. We didn't set the router. Post. Oh. No function clause matching. Ah, shit. That's right. That's right. That's right. That's right. That's right. It makes sense. Makes sense. We're getting a user here. We're getting a user here, but we have to set. Let's make a variable out of this. Oh my god, I already started writing JavaScript. all right. Sup, Sky Gold? How's it going? Long time no see. How have you been, girl? Jeez, I started rapping there. I only have some experience in Python, so this shit goes over my head. Oof. Just continue, man. Just ask any questions you have. Feel free. Doesn't matter what it is. Credentials equals, and then we're gonna make email user dot params dot email. Does that work? I don't know. We'll see. Really curious. Password is user params. What are we sending actually? Hold up. Password. What are we sending? Called with arguments, email password. Attempted to go with this. This is exactly what we're sending, right? No? Oh, they're strings. Is that the difference? Is that really the difference? So we pattern matched in our accounts. We pattern matched on no strings. Let's try again. Still didn't work. So we called it with this. And then we pattern matched this. Which to me looks the same. No? Oh, wait. No, huh? Okay, let's go here again. Bob Ross at bobross.com 1 2 3 4 5 6. Log in. Is this just outdated? Did it not refresh my code? Wait, let me check if it refreshes my code. io.puts hello world. It did refresh my code. How is this not matching? No function clause matching, just requires authenticated email and password. What the fuck? All right. Let's just take whatever the fuck we're sending. YOLO. And then we'll see. IO puts YOLO. It's undefined. Accounts is not available. I think it's because it's not compiling. Because I'm doing YOLO.email. Okay. All right, we hit the function. We're sending this. This is what we're getting. Let's copy and paste. Why is this not the same? Looks the same to me. Oh, here we go. Here we go. No password hash found in user struct. Fuck. All right, that's what I already thought, because they have this convention in comeonin to use password underscore hash, but we use password field. Yeah, we're shitty like that. So what we're gonna do instead, we're gonna use the other function, verify password. And it should return true or false. So we're still gonna go get an error, I think. It's still gonna go to error. Actually, we'll see. Maybe it's just gonna throw an exception because it doesn't find any matching case. I think that's what's gonna happen. Argument error. What does that mean? Oh, that makes sense. This thing takes a password and then the password hash. No clause matching true. Okay. So let's do a switch case here too. Case. Is it colon? Is it case colon? I can't remember what it is. Case do. When it's true, there's probably a better way than doing a case here, but okay. User. Isn't it just an if else? I don't know. I don't know what people do. Error. And then shit. We're not matching on this at all. And then we get the error or something. I think the issue is user might be null, right? Oh, that's also an issue here. No, we're banging. We're banging, boys. We're banging. We're breaking exactly. We're just throwing an exception whenever it cannot find a user. That's actually wrong. But sure. Okay, let's do hello world. How do I get the error here, though? Whatever comes out of here. Oh, there's no error coming out of here. Whatever, bro. That's a weird fucking case, but sure. I did it! We're logged in! Well, not really, but... So if we fill in a different password, it should say... Whatever, bro. Thank you. Far too kind. We're doing stuff. That's great. Oh shit, we're sending... God. Okay. So if... Oh, we're going back to new. We're sending the user back to new. That's not what we want. We want to send him back to login with an error message, right? But shouldn't this error be on the That's all right. We have docs on this too, actually.
You know what?
You can actually read the docs on this.
Really?
Where is the docs? Here. Session controller.
A ton of weed in the 90s.
Right, the 90s.
Create. Authenticate by email password. We're not that far off, guys. We're not that far off. It's asking account, authenticate by email password. Okay. Connect. Put flash. Welcome back. Put session. Configure session. Redirect. Otherwise unauthorized. Oh, we can just do that. Yeah, I'm okay with that, actually. If our account service is false, we just give him back unauthorized. Bam. And then you can figure out in the controller what that message is going to be. So we'll just do put flash on put flash error bad, but the error is gonna be error or unauthorized. Did I spell that correctly? Look at us go, chat. We're just building shit. User path show. Whatever, bro. Sure. Actually, we can just take whatever they did here and steal it. Configure session true. Look at that. Boom. Doing exactly what they did. We're so pro. If this, then do this, and then we're going back to session path. No, we're going back to login. That's what we're gonna do. I'm liking this. I'm liking this. This is looking good. Routes. I think we already have routes included, no? No, we don't. All right, login path. Is it login path? I think it's actually, I think it's user path. User's path. And then login. Because we put it in this shitty thing. All right, let's see if this works. Oh my god, I'm so excited. Bob Ross at ross.com. That doesn't exist, I think, that user. Shit. So you're right. It actually broke on the fact that it couldn't find the user. So we shouldn't use the bang here. What's the song? Oh shit, it doesn't actually show the current song. When you're a guitarist, but you listened to lo-fi hip-hop once. Or I'll send it to you. Damn, I thought all along you guys couldn't even know what song was playing. Sorry, guys. You guys got debated. Okay, so this kind of sucks. Oh shit, I paused the music too. Then the stream becomes so boring. This streamer, man, becomes so boring. Okay, so takes a password as input and returns a map containing the password hash. Takes a password as input, returns a map containing the password. I don't understand. I don't understand one thing, chat. We're hashing our passwords with a salt. Where is our salt? Is the salt... Is the salt literally password hash? Is that actually what it is? So somewhere in my application, I have to add an hash. Wait, let me try something. Let me try. Hold my beer, chat. Hold my beer. Okay. Let's say I create a password. Hashed password, which is bcrypt dot hash blah 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 hash password salt with Bob Ross as my password. Boom, it is hashed. If I want to verify password, no, wait, check pass hash key. The key used in the user struct for the password hash. What is the salt? Salt is just random data. What? It is just random data. Oh, you're not talking to me. You're talking to Kasha. Right. In the base bcrypt base hash password function. Hash password function. This one. But where is this stored? Something goes wrong. If this is like... I'm really afraid, guys. I'm really confused. Where is this data stored? This salt, it needs to know about this salt somehow, right? During the lifetime of my application. And if I store it in a database, and then when I reboot my application and the salt is different, that'll be really messed up, right? Because then I can never log into any of my passwords anymore, or any of my accounts anymore. So I'm a little confused where the salt is. It's random data that gets hashed. But how can it re-verify the password then? If the hash is different every time, like if I do verify pass, I assume what it's gonna do is it's gonna hash the password again and then match if it's the same, right? No? Is that not what it is? Have I been doing this all wrong all the time, all along? I'm only gonna new every time. Yeah, that's what I mean. But where is the salt? It's not in memory. If it is in memory, if it's based on time, it's wrong. New one every password. Yeah, that's fine. But if somehow it knows what salt to use for what password, right? Apparently, then, if that's the case, like if I do check pass, bcrypt, check pass, hashed password, or what did I have to send? Oh, it takes a user struct. Verify pass, which takes the password Bob Ross and the hash password. And it somehow knows what salt to use to match this string with this value, right? So somehow it knows which salt to use. But I don't know where it is. If I close my application, will it still be the same? So if I go and exit now, abort, and I reboot IEX, and I do another hash password call, the password is the same. No, it's not. The hash is not the same. It's not the same. Only the first part is the same. This part seems to be the same. And then when I verify password, which means that if I were to verify this password right here, it should also match. It shouldn't really, but this is also true. What? Crypto security is fun, right? What the fuck? What? I'm so confused, dude. What I always thought was, this is what is happening. You have some secret, some application secret, right? You have your secret. That's what you're gonna encrypt with. That's your secret. So you're gonna do hash with bcrypt or whatever. You hash your shit. Well, it's not encrypt. Sorry, it's not encrypt. It is hashing. Sorry, Lars. Takes a string, Bob Ross, and it hashes the password with this secret or something, or I pass the secret myself. Sure. And then it returns me this like hashed password sort of thing, which is like blah 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 blah, right? I save this in a database, but the secret remains the same. The secret is just somewhere in my environment variables, a secret that I would never change, because then if I change it, all my passwords are invalidated, right? So then I can do bcrypt.verify, which is gonna take the string, like Bob Ross, the hash password, and then the salt, right? The salt that I use, because otherwise it cannot compare. If this secret is different, it's gonna hash this string, and it will end up with a different password than the one that is hashed in the database, because the secret is different. So it's encrypted with a different salt, right? to make the password unique. Bcrypt. I want to know about this. Based on the blowfish cipher. Blah blah blah. Shadow password record. The prefix blah 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 in a hash string in a shadow password file indicates that hash string is a bcrypt hash in modular crypt format. The rest of the hash string includes the cost parameter, 128 bits salt, 184 bits of the resulting hash value. Okay, let's say you have a password 1E, 1E2, E3. Then someone else chooses the password 1 as password, they will get password 1, E5, E6, E7, E8. Huh, that makes sense. If people have the same password, you would otherwise have the same hashes if you were to use one secret, so to speak. Where does it... If your password is stored with a unique salt, then a pre-computed password hash table targeting unsalted password hashes, or targeting an account with a different salt, will not aid in cracking your account's password. Unique salt. Yeah, that makes sense. Yeah, it needs some sort of common structure, right? It needs some sort of commonality. If that's even a word. The algorithm, boys. Here we go. We're going in. We're going in, boys. Yeah, I already don't understand shit. And we're out again. Yep, we're out. Yep. All right. Good. Good story. Good story. There must be some sort of video on YouTube about this. Oh my god. I'm using a guest network when I'm streaming, but god. Didn't know YouTube was that bad when you first go here. So I'll go Bcrypt. Explained. Oh, you guys can't hear this. I don't think you guys can hear this. Let me play it on my main monitor. How am I gonna show this? All right, let's pull this one out. Bcrypt explained. All right, I cannot read the chat right now. How do I stream? Yeah, exactly. Window capture. Browser. Oh, it's black. God damn it. Alright, so that's not working. Let's do display capture then. Capturing my second monitor. You guys are gonna see an infinite loop, guys. Oh no. My main monitor. Shit. Infinite loop.
I learned about Bcrypt, how it protects our users from evil hackers, and also these algorithms are like their own little you do it. It's a very useful property. Hash, but it is nearly impossible
We
to
know
go
about this.
from the hash back to hello. These other hashing algorithms do the same thing. They're all the same.
They're all the same.
Differences are these two are pretty fast, but Bcrypt is designed to be slow. And that's a good thing. It protects our users from deadly hackers. So the reason
deadly
we want
hackers,
Bcrypt to
dude.
be slow
They're gonna kill
is
us.
because sometimes our databases get compromised. So let's say we have a
Databases.
couple users. We will call them Alice and
Actually,
Bob.
wait. I know what I can do. Hold up. Let me remove this. Later, boys. I know what I can do. I'm gonna watch it with you guys on my main monitor. I lost the window now. Shit. Completely lost the window.
And they sign up for our website. Alice is smart. Alice signs up with some random password that she does not use on every other website. But Bob
The deadly
is not so
hacker
smart.
boys, guys.
Bob uses a password that he uses on many, many other websites as well. Now, when these people sign up for our website, we have to store their passwords in our database.
Oh
So
no,
this is our database. Our users database. We have user ID, we have email, and we also have password. So when Alice signs up, we give her user ID.
Yeah.
We give her
I know.
email
This is like
and
easy.
password. Now, I'm gonna change these real quick. Him, because our many
Yeah. Password, plain
account.
text, bad. We don't want to do
Nobody
that.
can really guess. It's nearly impossible to get from here back to the original guess.
Cool.
Password is called a password digest. Then
Okay, here we
nobody
are.
can really guess
Here we go.
the
Here we go.
original password. In practice, this hash of the password is called a password digest, assuming this is a password. So let's change this. Instead of storing
digesting
this,
the
we use
password.
Bcrypt to generate some hash.
Woo!
So it's a much longer
Bcrypt.
hash. It's probably going to be around 30, 50 characters. And now, even though the hacker has obtained this list of passwords and emails, he doesn't quite know what this original password is. He can't take this and then try it.
This video
in
is not going to explain
this email
anything.
account because it's not an actual password. It's just a hash of a password.
So far, we know, right?
But even this is not secure enough. What hackers have done is they use what's called a dictionary attack.
Whoa.
And what they do is they take a list of common passwords and they pre-compile their Bcrypt hash. So for example, ABC123, let me in, password. They have a very, very, very long list of common passwords. And they generate all of the hashes for those passwords. These are all fake hashes, by the way. And now what the hacker does is that he takes these password hashes. This is now
compares them.
password
Woo.
digest. And he compares them with all the ones he has. And if any of them match up, then he knows the original. So this is not completely secure either for those unfortunate common users. So instead of just hashing this directly, what we use is called a salt, password salt.
Woo,
And this
salt.
salt can be anything we want. We will call it my salt.
Yeah.
It's just a
Perfect.
string. And the idea of a salt is that
That's what
instead
I'm
of
talking
hashing
about.
the password directly, you hash the password plus the salt.
Yes.
And then you store that instead. So now this will change. Let's make this up again. And this will also change.
Yes.
Even though we're storing ABC123, because we combine it with the salt before we compute the hash, this will no longer match with this.
Exactly.
So our
This is all the knowledge I know. This is, as far as I knew, this is exactly what I said, right? Adding a salt, making sure that, you know, it's encrypted in our way that we only know about.
One thing I forgot to mention. If the hacker compromises our passwords, he also compromises our salt. So the hacker can take that salt and then generate another...
What? How does he know if he gets our password, he knows our salt?
are safe. One thing I forgot to mention, if the hacker compromises our passwords, he also compromises our salt. So the hacker can take that salt
How is that
and
possible?
then generate.
Wait, does anybody know how this is possible? If they find our password, huh? Okay, I don't know actually. Just store the salt with the user. Oh, that would be one explanation, but that would be weird, right? All I'm saying is, like, if I store my salt in an environment variable on the server, if they compromise my database, they probably have my environment variable. That is true. If they, well, if they get onto the, if I have my database somewhere else, and my application knows about the salt, but my database does not know about my salt, then that's fine. Salt is unique for every user, though. Well, that's the thing, right? That's why I think you should have an application secret, and then you can also salt per user. I mean, I don't mind. Do that.
Another dictionary, and then try to get all of these common passwords out of our database. However, this is the point where Bcrypt becomes especially important. Remember that Bcrypt is designed to be slow. Because it's slow, creating this dictionary will take a very, very long time. If it was instead a fast hashing algorithm like MD5, the hacker could create this in like an instant. But he can't. Because we're using Bcrypt, this will take too long to be anything meaningful. So that's the whole reason Bcrypt is designed to be slow.
What? This was it? This is all the information? Really? This is exactly as far as I knew it. I just wanted to understand why if I go back to the code, why is it that if I kill my application and I run Bcrypt on a string, I get one string here, I run it again, I get a different hash, the password for both hashes still work. How is that possible? Where is this data coming from? And here we go to Elixir Bcrypt. And we're gonna look at the source code. Oh shit, sorry guys, that's very loud. Hash password, salt. When byte size salt is 29. The salt must be 29 bytes long. Okay. That's the base. This is the public part. Here it is, ladies and gentlemen, here it is. No, it's not. Generate salt, keyword get, options, log rounds. What is log rounds? The computational cost as numbers of log rounds. Default is 12. So Bcrypt is only effective because hackers are impatient. I'm still missing something. Binary bin to list. Generate a salt to use blah, blah, blah. Log round parameter determines the computational complexity of the generation of the password hash. Its default is 12, the minimum is 4, the maximum is 31. Legacy option is for generating salts with old hash $2A2 prefix. Only use this option if you need to generate hashes that are then checked by older libraries. Base gen salt nif. All right, let's go back to base. See what that is. Generate salt for use bcrypt. Takes a random, then the log rounds the minor. I've never seen this syntax. Nif error. Are you studying this shit? No, I'm not. But I'm just generally curious. I did study this shit before. I'm still like, I can't wrap my head around it. I can't wrap my head around it. I still cannot. Crypto strong random. This is the crypto. This is the Elixir crypto. Strong random bytes. Let's call this. Let's see what the fuck this does. I just don't get it, man. I'm just too dumb for this shit. Crypto strong bytes. This is, by the way, this means that we're not even touching Elixir at this point. We're just touching Erlang. So Elixir compiles to Erlang. So if you're doing this, I can't remember what this thingy is called. But we're not hitting the crypto library like this. Crypto. Is there a crypto library? Oh, there is. Strong rand bytes. It's not a thing. But it's crypto. This is basically from crypto Erlang. They should have like strong random bytes function. See? Generates n random bytes, randomly uniform 0 to 255, and returns the result in a binary. Use a cryptographically secure PRNG, seeded and periodically mixed with operating system provided entropy. By default, this is the random bytes method from OpenSSL. All right. There's also crypto randoms rand seed. Rand seed. And then we get a map back, which gives us bits. Okay. I don't know what any of this means, but yes, totally. I like it. Sure. I guess. I'm still really confused. Somehow, it knows how to decrypt. And then every time the hash password function is called, we're calling it with another. What is hash? Hash function. Hash. Hash nif. Binary bin to list password. Bin to list salt. It's Python. You're not supposed to understand this, but this is not Python. This is not Python. This is Elixir. What's up, Cinder? How's it going? How was your stream, man? Load Niv from Erlang. The Erlang biffs. What the fuck is this? I'm just diving way too deep, guys. I'm diving way too deep. What is happening? What's up, P carrier? I'm diving way too deep. Sup, Yuka? This is a bad idea. Oh, atoms is what they're called, by the way. By convention, most built-in functions, BIFs, built-in functions, are included in this module. Oh, we're in the Erlang module, but we're load NIF, so we're looking for. Loads and links a dynamic library containing native implemented functions for a module. Path is a file path to the shareable object dynamic library file minus the OS dependent file extension. What does that even mean? What does that even mean? Okay, let's continue. Yo, we're diving way too deep, but I'm really curious. You got 3 wins in a row. Shit, bro. What's up, Joshua? You feeling better yet? Didn't even notice that big Erlang logo. That's alright, man. Notice that on most OSs, the library has to have different name on disk when an upgrade of a NIF is done. If the NIF name is the same, but the contents differ, the old library may be loaded instead. Okay, that makes sense. So this... path is the path to the... So this loads in a module, like OS operating system specific modules. So SO files and DLL files, I think. Hopefully. How do we get here again? Wait, how did we get here again? We saw it in the... I think we saw it in here. Load NIF, yeah. Load NIF, file name join, code private dir, bcrypt elixir. Here we go. We're onto something. Oh my god. We're onto something. I want to see the path name. My code build dev lib this private bcrypt nif. Let's open it. Let's open it. Yo, we're onto something, guys. Holy shit. Oh my god, what is this? Cannot be shown because it's a binary. Where are we? We're in dependencies. Bcrypt Elixir. That's just a native implementation of Bcrypt. Could be. Here's a C file. And the underlying Bcrypt is derived from OpenBSD. Okay, this is the native implementation of Bcrypt. So NIF. Is this native? This is C, right? Yeah, C file. This is it, right? Bcrypt. Yeah, this is Bcrypt. We've got the source of Bcrypt. Oh, Lord. Blowfish, stream to Word, ciphertext.
Are you still there? To delete message, press 7. To save it
You need to accept that I won 3 games in a row. Anyhow, have a good time hanging out here again. I don't do it nearly enough. It's okay, man. It's okay. Catch you later, Rosarino. Thanks so much for stopping by. Okay. We're diving real deep. What is Blowfish? Blowfish is like an algorithm, I think. I've seen this before. Blowfish block cipher. Oh god, this is something we shouldn't know about, but I'm gonna look. I'm just out of curiosity. I'm just looking at it anyways. I don't want to understand. I just want to look at it and be like impressed. Look at this. Look at this, man. If anybody's gonna remember this. Okay, I think I've seen enough. All right. So in private, what is this? What is this file? Oh, okay. This is the Mac version. I think this is the Mac version of the SO file. If I click this, what does it open in? It opened in my terminal. Okay, whatever. Okay. Sure. Make file. What's in the make file? The NEFs are here. This is the C source. That makes sense. So we're loading it. Oh, okay. I think I understand. Okay. So make all is gonna do library name, bcrypt NIF, create a private folder, then calls cc. What the fuck is cc? Okay. C flags. And then a bunch of flags. With these flags. Okay. Sure. Whatever. Perfect. Totally. I'm fine with this, man. I just still cannot really understand what this is. Maybe we need to watch another video. Because I don't get it. I get what he explained. I just don't get how... If I run... Yeah, I don't understand. This is system C++ compiler. Oh, no, thanks, Lars. Didn't know about that. Is it like a global? If I were to exit this? Oh. No. C-lang. Oh yeah, I see. C-lang. Yeah. Cool. I see. You can do like, you can check where something is, where the binary is, right? Find binary. Or executable or something. Which CC. User bin. Is it lowercase cc or does it not matter? IP2cc. Look at that, man. Yeah, so it's lowercase cc as well. It doesn't matter. They just had it uppercase. I think C-lang is just pronounced K-lang, by the way. Really? So it's not C-lang, it's clang. Clang. Is it really called clang? You pronounce it as clang, really? Alright, interesting. Yeah, I still don't get it. As much as I want to understand how this works, I still don't understand how this works. So this is just calling... This nif part is just native, basically calling the actual Bcrypt C code to generate the salt based on the the complexity. The computational complexity. Wait, let me read it on stream. Hello, LLVMers. I just wonder how I can pronounce C-lang. C-lang, C-lang, Klang, K-lang. If you're pronouncing it cool. When was this? 2008. Klang. We've been pronouncing it KL. Next part, a non-text attachment was scrubbed.
Well, will life give you a
That's an actual character. What the fuck? Yo, Steph, welcome back to the Cats community. Thanks so much for the resub. Can we get some one of us in the chat? Also, can we shout Steph out? It's an amazing streamer. How have you been, girl? Look, that's an actual character. What the fuck? Alright. We've been pronouncing it clang. How have you been, girl? Clang. Wow, that's actually weird. I don't want to think about that. I don't want to know about that at all. Okay, so let's just continue. So on load nif, call load nif, which is gonna do call bcrypt nif, which is basically getting the C Erlang compiled one, which is built by the makefile, I think. So in here is a makefile which compiles, which basically makes an Erlang version that internally calls this. Basically, is a compiled version of the Bcrypt version. Where is that though? Is that these two? So it compiles this in the make p private. So this is a compiled C file, Bcrypt C file. Is that correct? Yes. That is correct. Shut up, Richie. Right. All right, I think I understand. Okay, but that doesn't explain everything. That still means that I still have to understand Bcrypt before I want to understand how this works. Because I will not get the answer to my log complexity question here. Log rounds Bcrypt. Bcrypt log complexity. Recommended rounds of Bcrypt. No, I don't want to know about this. You should use the maximum number of rounds which is tolerable performance-wise in your application. Yeah, I think I'll just keep it the default. Okay. For some concrete numbers, he suggests a reasonable goal would be for a password verifying hashing, it takes 241 milliseconds per password. Thomas initially wrote 8 milliseconds, which is wrong. This is a figure for a patience of 1 day instead of 1 month. That still lets you verify 4 passwords per second. More if you could do in parallel. Thomas estimated that if this is your goal, about 20,000 rounds is the right ballpark. In theory, for my application, I can actually probably put this to the highest amount. Logging in would take a little longer. Does login take longer? I think so, right? Yeah, login takes longer. Yes, I think so too. Oh my god. Because, well, I'm the only one logging in. So I think I'll be the only one logging in. So I think that I wouldn't even know how long it would take. Let's try it out. Let's actually try it out. How long would it take if I put in the highest complexity to verify 1 password? I think we have 2 bots in this stream. True. Log rounds config. Can I change that here? Let's put the log rounds to, what was the highest we could make it? Highest was 31. Yeah, I don't think it knows about config. But I think the config is set. Config dot here. Oh, there is a secret keybase already. So is it using this then? Or no? I don't know, guys. Okay. Part of it was public. So let's see. Log rounds gen salt. Base. Yeah, let's get the base. And then just call this function with our own gen salt. With a log of whatever. Okay. Let's alias the bcrypt base. And then we call hash password with a password. Okay, let's first create a password. So our password is Bob Ross. That's our password. And if we call base.hash password, hashed password equals hash password, which takes the password, and then we have to gen salt base dot. Is this a public? Yeah, this is a public. So I can do bcrypt dot gen salt, calling that with log rounds. So this is the logarithmic complexity, which is going to be 31 because that's the highest. And then legacy false, which we don't have to pass because I think it's by default false. Yeah, it's by default false. So that is all it takes. Bcrypt gen salt is undefined or private. Did you mean any of gen salt? Wait, I thought I did that. Oh, I forgot the underscore. Oh my god, look how long it takes. Yo. Why is it taking so long? Well, it's a 31 complexity. Oh my lord. It's 100% CPU usage right now. It's trying so hard to solve the password. All right, this is like taking forever. It's definitely not 250 milliseconds. Oh shit. Will it ever finish? I don't know how long it's gonna take. 99%? 100%. Shit. Shit, bro. What's up, Everblade? How's it going? Are you programming your kickbot? What is my... Oh my god, my kickbot. No, please. I'm not kicking anymore, guys. I can show you guys my badass kick, but... Oh. Alright, I don't think this is ever gonna finish. Abort. Alright, we're good. Let's try it again. Let's alias bcrypt again. Let's figure out how slow it is when we lower the thing a little bit. The default is 12. So if we were to do password Bob Ross again, but let's first just do bcrypt base or base dot hash password is this Bob Ross, and then bcrypt gen salt of okay 12. Let's start with 12. That's like pretty easy. That's like really fast. Let's do 18. 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Jesus, okay, this is already taken about 21 seconds to generate a password. And then if I want to validate that password, that'll be check nif. I think it's a private one, right? Let's see, base.check niv, check pass niv. Which is gonna be exactly this. Fuck. Gonna take Bob Ross and then the stored hash, which is this crazy of a hash right here. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That was correct. That is true. Yeah. So if it's 0, it's true. If it's something else, then it's false. So it takes... Okay, so a complexity from 12 to 18, which is 5 up, basically went from, well, maybe 100 milliseconds to 20 seconds to hash a password. This took like 700 milliseconds or something. That took like 1.5 or 2 seconds. Four seconds. You went from 2 to the power of 12 iterations to 2 to the power of 18. So there's a lot more. Yeah, that's true. The power of 18. That is quite a bit more. A tiny bit. So how much was 2 to the power of 31 then? That's just unusable. Jesus. It goes through this amount of iterations. Yeah, I just don't understand. I still don't understand this shit. But it's definitely interesting. That's like max int territory in C, probably. Yeah, it could be. What programming languages do you know? The ones I've worked with are PHP, Ruby. Now that I'm thinking about it, it's all like super dynamic languages. PHP, Ruby, JavaScript. Elixir? Yeah, PHP, Ruby, great start. That's what I'm thinking. The more I start to like talking about this, the more random it gets. I should actually go to bed before I pass out on my keyboard. Good night. Yo, good night, everybody. Thanks so much for stopping by. What's up, Kosi? Holy shit. How you doing, man? Okay, so in theory, I could actually crank up this password just a little bit. This one. The config I could just put up. I can turn up the config and set it to like, I don't know. I could probably set it to 15. Was 15 fast enough? 1, 2 seconds. 3 seconds to log in. That's probably too slow, right? I think 14 is still fine. It's like 1 second. About 1 second to log in. That's all right. That's just to create the hashed password. And then if I wanted to... If I wanted to check that password... Hashed... Password. And then I just give it something random. Random. Took about 1 second. Yeah. The time should about doable every time. What do you mean? Bye, boy. Oh, you guys going to sleep as well? Good night, Steph. Thank you so much for stopping by. Sub Richie. Good night. Every 1 increase will double the time. Yeah. Yeah, that makes sense. Thank you for spreading your wisdom. Thought you were going to bed. No, somebody went to bed. Everblade went to bed. So I said, have a good night. Don't pass out on the keyboard. Oh, wait, I was reading... Wait. We should all go. I should go to bed though, because I gotta work. But let me commit my code and then go to bed. Okay, we learned a lot today. We learned about Bcrypt that I still don't understand how the fuck it works. Right, now wishing you good night now. I got baited. Alright. Well, shit. Alright, we learned today how in the shittiest way possible we could set this up, but it's working, which is all that matters. We didn't really split up our domains well enough, but that's okay. It's working. Do I really need comeonin? Actually, let me check. Do we really need this? Isn't just Bcrypt enough? Mix deps get. Comeonin is still in there. Okay. Kind of awkward. I don't condone con artists. Cowboy. Yeah, man. Cowboy. I can't remember what that's for, actually. Let me check. I think that's a web server. The Cowboy web server. Yes. Simple, fast, small, fast HTTP server for Erlang. Cowboy is a small, fast, and modern HTTP server. That's what it is. It's a tiny web server. Small and fast sounds familiar. Feels bad, man. My life. Okay. Sure. Should we add docs here? You know what? Let's commit this and go to bed. Let's do it. Oh, this thing still breaks. This one still breaks. Let's check this. Let's do it really nasty and super imperative instead of doing it the right way. So Elixir just made mint. Elixir mint. Oh, what the fuck? 3 days ago. Whoa. All right, Cursive, how's it going? Mint is a low-level HTTP client that aims to provide a small and functional core that others can build on top of. Mint is connection-based. Each connection is a single struct with an associative socket belonging to the process that started the connection. Since no extra processes are started for the connection, you can choose the process architecture that better fits your application. Okay. I don't think my version has this, because I'm a pretty old version. Let's see. Let's see if mint is defined. Oh. Mint. Mint. Wait, does that mean mint is there? Wait. Let's try this. Yeah, that's what I thought. I think I can just do YOLO Debolo. Then it was, yeah. That's what I thought. It doesn't actually mean that the module is there. Yeah. Mint HTTP is not available. Yeah, exactly. My version is a little old. What's up, Engie? Enage? How long have you been doing this? Today? Streaming for 3 hours. What's up, Connor? How's it going? Cool. That's nice. Mint may seem cumbersome to use than most other HTTP libraries you used to, and it's true in many ways, but we're providing a low-level API without determined process architecture. Good use case for Mint is Gen stage. This is specification for exchanging events between producers and consumers. Okay. Yeah, I don't know what any of this means. I'm pretending that I do, but I actually don't. I do what they talked about before. I don't know what the benefit is. This part, I still don't know. Like, I get that there's probably going to be a lot of libraries building on top of this now, but I don't know what the alternative is. I guess Erlang's thing, which is cowboy, is probably what a lot of people like. I literally just googled cowboy. That's like every single time you're programming something, that's just what you do. You just search for cowboy and then you realize that that's just a way too generic search, and then you find something. Just like searching for Elixir. Or probably not. Well, it'll probably find the language for me because I'm a dev. But it used to always give me other... Oh, I started like Googling Elixir images, and then you will just get a random Elixir. Yeah. Because I wanted to show the language. Same for Ruby, I think. I think you might not... You might get the language. Yeah, you do. You just be happy for once to see me. Feels weird, man. First version of Mint has just been released. An experimental library trying a new approach to building HTTP libraries, so don't expect a full stable API yet. Cool. That's exciting though. The optimal number of rounds will change with your processor. Ideally, you would benchmark how long it takes on your processor and choose the number accordingly. I want to try something. It shouldn't work. Yeah, it shouldn't work. Should it work? I don't think it should. All right, let's try it. If I hash a password, Bob Ross... No, actually when I retrieve the password here again, the hash nif, no, the check nif, which is in base, over here. Check pass nif. What does this even do? I guess... No, I don't understand what the fuck this does. What the heck? Whatever. Okay, so... we do some sort of like binary comparison here. But... verify. Yeah, I don't know what this does. I go here and it's just two methods. But this one doesn't have an implementation. I don't know what that means. This one also has that. Anything with nif is that just forwarded to like the... It means it passes through, so it goes to the next one, which is also the same. So this is just for documentation purposes. They're saying you can either do this, but you can, in theory, you can just send anything. Yeah, okay, that makes sense. But then it does nif error not loaded, which is not true. Only when these are empty. Oh. I don't get it. Maybe because you load the nif on Erlang, it will just... So if I load this NIF, let's do this. I think it's already loaded. Let's abort first. Yeah, let's load this NIF. Does not match if library module name Elixir Bcrypt base. Right. Okay, I see. I get it now. I get it now. I get it now. I get it now. Okay, yeah. I get it. The compiled version, the Erlang compiled version that was in the dependencies here. Jeez, I'm learning so much about internals, even though I don't even know the basics. We're just going deep into the fucking shit. Okay, let's go back to Bcrypt, private. No, wait, this wasn't the folder that I was in, right? Was I? I was in a different folder. Oh, here. Elixir are cats. Deps. Bcrypt. Here, this is where it was. But there's also a build folder, which contains the Beam, the Elixir Bcrypt Beam stuff. So that's the Erlang stuff. What is this? Didn't you like need to work in the morning? Yeah, but I'm just almost. I want to understand. I want to understand what this is. But that's true. I really should go to bed. Alright, Bcrypt Elixir. If we go to that make file, we were compiling. Yeah. So we're compiling something for Erlang or using Erlang. I don't know what the flag, the C flag I is. But we're passing the Erlang path to it. So I assume that it's like compiling an Erlang library with the C flag inside that then uses the same namespace as this, because when I imported it, you could see that it's not matching the same name, right? So it's saying I want to load this Erlang NIF inside of the global scope, but the library module name is Bcrypt base. So this can only be imported inside Bcrypt base, which is exactly here, right? Good night. Have fun tomorrow. Yo, catch you later, Joshua. Thank you so much for stopping by. You enjoy tomorrow as well. Enjoy sushi, man. So it's loading a NIF file for Erlang that has its own module prefixed Elixir Bcrypt base, because everything in Elixir on the Erlang namespace is prefixed with Elixir when it's built by Elixir. So in order for us to use it, we would need to, if we were to make an Erlang module that we want to include, we would need to prefix it with Elixir to then match it with this. So this library has a module which implements this. Check pass NIF. And if you don't pass anything, it will throw a NIF error, not loaded. So we would need to know what that compiled version looks like. I wish. I don't even know how you do that. Is it in here? C source is in here. Check. Pass. Oh, here it is. So this is coming from C. Erlang nif func. So this is a C nif for Erlang. Because look here. Check pass. Erlang nif init. Here it is. Erlang nif init. Elixir base. And then the nif functions here, which is an array of hashes. Which then maps, or is it a tuple or something? I don't know what this is. Gen salt nif. But these are native implementations. So this just passes. I get it. We did a, so this just checks the native bcrypt check pass nif, which is the bypass bcrypt check pass, this one, which is gonna do all this shit, and it's taking the arguments from the Erlang environment. I want to see the complexity though. Oh no, that's not in check pass. Check pass, it is in gen salt. That's where it is. So inside gen salt, we take complexity. Lograms here. Why am I even doing this? Bcrypt init salt. Yeah, so here it checks. If it's bigger than 31, then use 31. So you can, in theory, still pass 500,000. It would just, like, go back to 31. And it would do the salt plus 7. And it would start with the prefix. Is this printf? What is this? Write formatted output to sized buffer. Yeah, I don't know what any of this means. And then a base 64 encode. Which is gonna do this every time, no? Is it calling itself or not? Where is this using these lograms? Salt. Bcrypt salt space. Plus 1. So this is the salt plus 1. And then the string that it needs to format to. And you have minor, which is an int. Wait, this is doing a lot more shit. Hash pass. Oh my god. Oh, I'm supposed to be in bed already. But I'm learning so much. Ridiculous. Core bcrypt function. Yeah, here it is. Oh my god. What am I looking at? What am I looking at? Like a kid in a candy store. I want to figure it out. Computer power doesn't increase linearly. 2 to the power of x should be fine. Not willing to leave because he's finding all new shit. Yeah, exactly. I'm such a fucking nerd, man. Oh, here we're hitting blowfish. what is this, man? What am I even looking at? And then tomorrow's I'm so tired. It's bedtime, yeah. I'm just looking at all this shit. I'm so like flabbergasted by this shit. Wait, what is this? This is the hash pass. And if it did finish, it returns 0. Otherwise, -1. You keep going, you won't remember shit? Oh, that's not true. That's not true. Alright, yeah, let's call it a day. Let's commit this code. We got something working. We got like semi-basic login working. Except for the fact that when the user is not there, it fails. But, you know, if the user is there, then it works. Let's see. Repo jizracats.repo.all jizracats.accounts.user. So we have 2 users. So if we just search for a user that actually exists, then the login actually works. 1, 2, 3, 4, 5, 6 password, login, you're logged in. Beautiful. Go to login again. If I pick a user that doesn't exist, it breaks. But that's okay. We'll fix that. We will fix that. Do I want to commit this? Probably. Let's commit this. Oh, if we cannot find a user, we should also return this. We can actually easily fix that. Instead of the bang, we get nothing. Shit, how can we do that? I can just do a simple if, but I don't want to keep that code. This is really shitty code, which is fine. If no user do done. I think this works. Alright, it's really shitty code, but it's fine. I think it's alright. Shit doesn't work. Change user. Change user. Change user undefined module. Fuck, I don't know how to do this. Unless, is there unless? Oh my god, there's unless. Elixir. This is really bad. I'm just making it super imperative. Case cond. Cond. If unless. If do. Unless. Unless do this. End. Return. How do I return? Fuck. Return Elixir. Fuck. Scheiße. Oh, this is so bad, guys. This is like you just cannot do imperative in his language. That's just not how that works. They just like make you, they just stop you from doing it. Okay, whatever. This is gonna break too when the user doesn't exist. Because it's gonna be nil. Alright, let's just do it. Okay, whatever. Case user do. Nested case. Oh no. This shit. If nil. This is not how you should do these, but I'm doing it anyways. Otherwise. What is this? This should work. It does not work. It doesn't compile. Nested case. Elixir. Boyd, you really gotta go to bed. Oh, this is not good. All right. Let's just commit it as if everything is fine, even though it's not. We know that it's a bug. It's fine. It's whatever. Sure. Commit it. Get done with it. Add first implementation of login. There's a bug in this code. If the user cannot be found, it breaks. Done. Publish. All right. Thank you guys for stopping by. If you're on the YouTubes, sorry for deep diving into the Bcrypt implementation, but we learned a lot. We're gonna continue this later. We walked through the steps that were needed in order to build a login, and we kind of did what we need to do. So that was good. Thanks, guys.